Hi, and welcome to the 24th edition of On Data and Design. Let me just check that everything works. Looks good. My name is Darian. I'm the co-founder of Super.studio. The co-author of the book Visualizing Complexity. Maybe you saw it before at somewhere in some bookshop. And I'm the initiator of the On Data and Design event series. We started several years ago. We started actually in Vienna and as a physical event, moved to Switzerland and Berlin. And at some point we went online, and that made us global, and we had possibilities to have amazing speakers from all over the world. And tonight we will have a topic which is data and maps, and I'm very happy that I have really three super experts in the topic and in the field. Probably you already heard about them. It's Craig Taylor, John Nelson, and Nico Belmonte. Today, initially, the idea was that I will have a co-host, Thomas Schulz, who is also a Swiss known cartographer. And he should have done the co-hosting with me because he's more the expert for the topic of maps. And unfortunately, he cannot participate for private reasons. So Thomas, all the best. Sorry, you're not here. And we have also tonight a sponsor. So a special thanks to our sponsor of today, Carto. The cloud native spatial analytics platform. With Carto, you can create maps, focus apps directly from BigQuery, Snowflake, Databricks, or Amazon Redshift using DeckGL as the visualization library. Render large amounts of data and perform analytics without moving your data, and start your 2 weeks trial and click on the button below in YouTube. So support Carto. Thanks for Carto for supporting us. And yeah, all the speakers, so kind of how does it work? All the speakers will have 20 minutes for their talks. During the talks, we will collect the questions in Slido. So you have the link just below in YouTube. Please ask questions and upvote questions. I will remember you after the first talk. And and after all the talks, the 3 talks, we will have the discussion round, and we have the possibility to answer the most upvoted questions. Yes, and I'm really excited. So Craig, would you like to start? The stage is yours.
Absolutely. Let me just share my screen. Okay. So I'm hoping everybody can see this. Right, okay, yep, hi everybody. My name is Craig Taylor and I head up our data visualization team at EatoWorld. So my talk today is going to revolve around creatively visualizing transit data, the how and the why behind some of my animated visuals, and a kind of behind the scenes look at some of the innovation and R&D work I'm doing at EatoWorld at the moment. So one aspect of my work at EatoWorld is the production of these kind of cinematic visualizations that depict clients' data in new and interesting ways. We work with all sorts of clients, from local councils to likes of TomTom, Facebook, Department for Transport. And the idea in the creation of these visualizations is that we try and tick 3 boxes: engagement, insight, and narrative. So we like to think ourselves fundamentally as interpreters of data. And through this, we like to create animations which are visually striking, enough to grab audiences' attention and encourage engagement. We understand the importance of insight, and we have lots of clever software that we're able to ingest huge volumes of data and derive insight over a large temporal scale. And perhaps most importantly, we are storytellers. Every visualization is kind of like a guided user experience through a data set they may or may not be familiar with the hope that by the end of that visualization, the user has a clearer understanding of what we're trying to show them. And the show reel behind me kind of showcases some of them examples. I'll skip through it because I haven't got long. So I want to talk a little bit about innovative transit visualizations, the topic of art versus insight, and where I kind of see my work on that spectrum. Like I said, some of the work I'm doing in innovation R&D at EatoWorld, and then do a bit of a deep dive into some of the bus stories animations that we've created with bus data. And I just want to talk about visualizing occupancy data as well, which is a really interesting metric for bus data that we can be quite creative with. So art versus insight, what does that mean? Well, I don't think these terms are mutually exclusive. I feel like the success of a 3D visualization should sort of straddle both these spaces. Having both an artistic and insightful data visualization in that 3D mapping space is incredibly powerful, and it's something that I try to achieve with each one of my visualizations. However, sometimes the scales are tipped in either one of them directions. For example, one of the first projects that I designed was coral cities. This was a really simple concept at the time, looking at drive time metrics. So all we're doing is looking at how far you can get within a city within a certain time period. And the idea here was to create these kind of coral-like formations, which were very much on the sort of artistic end of that spectrum. So the resultant visualization was, kind of mesmerizing. It was quite beautiful to look at, but there was no insight in it really, other than, this is the catchment area that we're looking at. And on the other end of that spectrum, we produce a lot of sort of data visualizations that are more insight driven, like this one here that's looking at ghost buses in Chicago. And the concept of a ghost bus is a scheduled bus that runs but has no vehicle assigned to it. So it's just a functional visualization showing the sort of brighter tadpoles, I guess, are the ghost buses, overlaid with some sort of simple metrics that show that the volume by hour. And then kind of in the middle of that spectrum is where I kind of like to sit the visualizations. And this is something I produced a few weeks ago, looking at electric buses in London. So it's kind of insightful. We can see the buses traveling throughout the network. We can see the volume of them and what routes they're going on. But it's artistic as well, because there's obviously a lot of design that's gone into the design of these kind of atomic orbs with these sort of electric tails as well. So experimental and fun, and kind of a mix of the both worlds is where I kind of like to sit these visualizations. So innovation and R&D, this is kind of a big topic for me at the moment, especially at Ito World. And it's not something that I discuss, on social media. We don't necessarily share visualizations of the stuff we do behind the scenes, because it's quite complicated. But we manage huge volumes of data and constantly looking at ways of validating them tools, validating the models that we look at and gaining insight from the data. So we have a set of tools that allow us to rapidly prototype designs, and as well as garner information about these bus networks and models. And a good example is these sort of animated visuals. So what we're doing here is looking at how complex bus data is. We rarely work in one dimension. Most data for this public transport exists in multiple geometries, multiple geographies, multiple periods of time, and we're always looking at multiple different metrics associated with it. So that could be delay, that could be on-time performance, it could be speed profiles, etc. So we do a lot of work looking at static charting, like in the sort of top left, but we like to sort of experiment in 3D space, because obviously we have an extra dimension that we can look at data on. And if you have a look at this line network here, it's showing delay over the course of a line network, and by stacking them lines on top of each other, we can start looking at how that sort of pans out throughout a day as well. This is an example of we have a lot of small multiple visualizations where we look for anomalies, for example. I won't go into too much detail on this delay prediction because it's quite complicated and it would take more than 20 minutes to describe. But essentially here we're looking at how delay propagates over the course of a line, and we're using these kind of small multiples to identify outliers. So the brighter areas are, areas of more common data. But then we can start binning that into heat map data like this. And this allows us to rapidly look at lots and lots of different data very quickly, and outliers become immediately apparent rather than scrolling through sort of each journey itself. And this is a good example as well, how we sort of use animation and this concept of space-time cubes and analyzing lots of data over, lots of different like axes of time and space. Here we're looking at all sorts from occupancy to delay, I think. And again, we have time, and we have date, and then the sort of the z-axis is the metric we're looking at. So by analyzing data like this and creating these animations, we're able to sort of scrub through a lot of data all at once. It's not just charting data we look at behind the scenes. Obviously, we like the map, and this is an example of how we're showing the change in delay from a bus from one stop to another in a chart, which is in the bottom right, but also how we can map that on a map as well. So the higher the point and the redder the point, the more the delay is on that particular stop. So it's useful for identifying pinch points in that network and seeing where a bus has increased delay from one stop to another. Animation is obviously a big part of the work that we do at Ito World as well. And the top two examples here are looking at, again, that sort of change in delay between stops of a bus network and how that varies over time. So we can analyze the whole data set as this kind of animated scatter plot, but we can also augment that with this kind of simplified chart at the bottom, which just analyzes the hourly total average rather than the individual metrics as well. So lots of different ways of looking at data, experimental ways as well. In the bottom left example, I've had a look at this kind of, I guess, equalizer type visualization that shows how delay propagates on different parts of a bus network. And the bottom right example shows how we sort of use clustering algorithms to actually understand the distribution of delay for a stop. So is a stop showing, large delays all the time, or is it, some buses are delayed and some buses are early? So using these sort of cluster algorithms to animate these over time is really, really useful. And I guess all that culminates in this ridiculously confusing and rather overindulgent 3D chart, which should never exist, but for the purpose of this presentation, it does. So it's complicated and it would never see the light of day, but it is interesting actually, because it shows the complexity of this data we're sort of dealing with and a sort of, I guess, a novel way of analyzing it. So we have the stop index along that x-axis. That's the sort of, the index of the stops along the route network. And then we have the offset in time along that kind of stepped y-axis. So that's showing all the individual journeys. And then for each timing point, we've taken, 60 days worth of data and we've binned all that delay data into this sort of histogram of, 3D bar charts showing where most delay exists. So basically what you're looking at is color and height. So the sort of big red areas, which you can see sort of congregate around the busy commuter zones, which is what you'd expect. But then it's also interesting to see that sort of blue areas where the bus is early is trying to pick up that time as it maybe hits its sort of timing points. So lots of different ways of visualizing sort of the sort of data behind what we do. Okay, so this next part of the presentation is looking at pretty 3D maps, I guess. So I want to do a bit of a deep dive into some of the bus stories that I looked at last year. So I spent a lot of time looking at data from the Bus Open Data Service, which is BODS. It's a platform that Ito World developed for the Department of Transport. And I wanted to use this data to create these kind of immersive environments, which not only showcase interesting stories of data, but also, make the most of the contextual data around it and sort of create these kind of immersive, quite engaging environments. And so these stories existed as 3 different chapters. We had the hardest working bus in BODS. Now, this is the bus that navigates over the sort of, ascends and descends over the most steep terrain or topography over the course of its journey. We have one of the longest and loneliest buses, which I'll come on to in a bit. And then just simple, visualizations showing the longest journey in BODS as well, but all within these kind of nice little vignettes. So the longest and loneliest bus, a sad tale of one of the most isolated buses in England. What do I mean by that? Well, this is the bus that has least interaction with other buses as it navigates the course of its route. And so it's actually quite an interesting process in terms of the sort of data side of it behind it, which I wanted to go through. So when grabbing the data, we obviously got the data from BODS. I looked at a 3-hour window of that data at 5-second interval, and anything more than that would just be too much to actually analyze and sort of work out this metric from. And so each individual route from that bus was isolated in a loop. And then for every X interval, a calculation was made to work out what the closest bus was to that point. And so doing that for, so on the sort of diagram you can see here, the orange points are the GPS locations of a bus trip, and then the blue points are the closest buses that corresponded to that individual GPS point. So over the whole of the network, we then had an average to distance bus, which is taken for each route. I also wanted to factor in route length as well, because I didn't just want short journeys. So each one had a 50% weighting. And once that data table was sorted, one of the top routes was this SDVN route came out on the list, and therefore is one of the longest and loneliest buses in England, which is a metric that no one would ever need to figure out, but I thought it was quite fun. Okay, so yeah, my interest in creating these kind of 3D vignettes took me on a journey visualizing some of the most scenic bus journeys in England. So these visualizations here are kind of overindulgent, I guess, but they're just, you know, these kind of nice tourist style visualizations showing these buses traveling through some of the most scenic areas in the UK, complete with sailboats, hot air balloons, and paragliders. Just because nothing is to scale, obviously, but you know, just a bit of fun while animating this bus data. Okay, so occupancy data. So this data is really interesting. It's a concept that I've been working on a lot while analyzing transit data, and understanding actually how a network is being utilized from a passenger point of view is really valuable for planners and operators in sort of optimizing them bus routes. The following visuals in this section showcase how we can interpret this data in, I guess, creative and kind of abstract ways. So this is an early concept that I was working on for bus capacity. So it's sort of a prototype and visualization that displays what occupancy data is. And here you can see that sort of network, and the taller the fence and the redder the fence, the more full that bus is. And you can see how that propagates over the course of a day and on different routes. And so I wanted to take it one step further. One of my previous visualizations looked at this kind of idea of piles. And this is looking at just total number of buses on the BOD service in the sort of data set. So what I wanted to do is take this idea of visualizing volume in a very sort of physical sense, and understanding sort of volume of a metric. I also got experimenting with kind of real world physics. So actually giving everything in the scene an element of physicality, so that when these data sets sort of fall on top of each other, they create these kind of beautiful sort of resting mounds. Basically what I'm trying to do is create mountains and trying to figure out a way of creating this kind of these mountains, which is actually quite difficult. I had lots of different methods of doing it, from isolating data sets, figuring out when the sort of the change from one state to another, so when people were getting on a bus happened, and then kind of, I guess, offsetting that in a vertical axis, creating these kind of pyramidal distributions, assigning these balls to it. And what I'm doing here is basically trying to create a state so that when this data falls, it creates these kind of nice looking mounds, which is, again, kind of overkill for what I'm trying to do. But the result visualization shows quite an interesting pattern. So here we're looking at where people are getting on a bus, so a positive net change between stop to stop. Each one of these spheres represents one person, and the mounds represent the pattern of, or the volume of people where they're sort of changing, getting on the bus. But actually I wanted to sort of, I guess, evolve that concept as well to create something a bit more organic. I wanted to create these kind of mountains that sort of raise up from the floor. And the way I figured of doing it was almost like creating data rain, right? So whenever there was a change from stop to stop in terms of the number of people getting on or off, that data set would fall from the sky. So say 10 people got on a bus, 10 spheres, or whatever they are, would fall from the sky and start creating these mountains. And then you can start playing around with the topography of that data and creating these kind of visual mountain ranges and peaks that kind of rise up from the floor. And that spawned this I guess transit mountains visualization, which is showing, so all the blue glassy spheres are the buses, and the the topography that's being built over it is where people are getting on the bus, which I guess is massively overkill for showing this data. I mean, you could just show 3D pillars, but I guess what's the fun in that, right? Okay, cool. So this is kind of an interesting concept. I guess it's sort of chicken and egg type thing, where a chicken lays an egg, but it's actually a bus laying a person. So what it's showing is, so whenever a bus arrives at a stop, it deposits a number of spheres. Those spheres relate to the number of people that are getting on or off the bus. And as them spheres are deposited, they kind of push the other spheres out. So everything has this sort of like physical geometry to it, and it all interacts. So what you end up with is these zones of similar data to what we've seen before, these kind of areas where lots of people are getting on the bus or lots of people are getting off a bus, but it's just a different way of visualizing it. And again, this is where people are emptying the bus. So the difficult thing in trying to wrap your head around this is that even when people are filling the bus, you're showing spheres depositing, which is kind of a bit confusing to think about. But I couldn't think of another way of doing it. And finally, this is completely overkill bus data, but it was actually part of some R&D work into visualizing emission data. And so we sort of created these underwater gazers that kind of exploded. And so the pink ones are people getting on a bus, the blue ones are people getting off a bus, and they're scaled proportional to the volume of that data. So, big pink explosions are lots of people getting on. This should never be used for any form of insight, but it's quite mesmerizing and I guess quite nice to look at. So there we have it, a kind of whistle-stop tour of all things innovative and transit-orientated. Yeah, I hope you enjoyed it.
Perfect. Thanks, Greg. It's really.
Stop sharing?
Yes, please.
Yeah, cool.
Thanks. I'm really looking forward to see the questions. There are already very interesting questions on Slido. So please, for everyone watching, if you have questions, let's collect the questions and answer them afterwards. I guess there are a lot of questions because it's really very inspiring work. Let's continue. John, are you ready? I hope we will have a good screen share this time. Let's see.
Yes, yeah, fingers crossed. I now greatly regret my positioning behind Craig. Shoot, Craig. Thinking that was magnificent. That was beautiful. Thank you for sharing that. It's inspiring. And there's a lot to be said for beauty in work. The elegance and the beauty of something is engaging and it draws in eyeballs. So great work. My name is John Nelson. I work for a mapping software company named Esri, and I'm on a team there called Living Atlas. Living Atlas is a lot of fun for me, and I think everybody else on the team. It's a little bit like an ecosystem of the global mapping community. There's a demographer, there's environmental scientists, there's an oceanographer, there's one of everything, it seems like, on this little microcosm of the mapping world. And it's great. It's so much fun. And what I do there is create user experiences. So I'll design applications by waving my hands and drawing pictures and making mock-ups. And then smart people actually make these things real, which is a magnificent thing to behold. I'm honored just to be a part of it. And I'm having a lot of fun. And speaking of fun, when I'm not doing those things, I'm just playing with data that's in Living Atlas. Living Atlas is a little bit like Wikipedia for maps and data. And people can contribute their data if they want to make it more widely available to folks who can use it in their geographic information systems, either in the desktop or online. And it's also where people who do mapping can find data that's made available by federal governments or international agencies or even local governments or individual customers. Anybody who wants to share their data, it's available to them. And I goof around with that data and I make a lot of maps and I have a lot of fun. And if I make a map, invariably I I can't keep that to myself. I'm going to share how I did it because I want other people to have the same sort of fun that I'm having. I just love it so much. And I write blogs detailing the steps on how I made something from data all the way through to layout and sharing. So that's really fun and really rewarding. And it can be a lot of typing, a lot of screen capturing, and I'm lazy. And so over time, I've found that, it's actually a little bit easier to just record demos and share them on YouTube, and people can see those videos themselves. And so I have a YouTube channel called John Nelson Maps. And a lot of the times my blogs are packaging up these videos and doing some outlining and showing some examples there. But feel free to check this out. A lot of it is cartographic shenanigans, goofing around, ways of styling, ways of understanding data, the dimensions of spatial data, that sort of thing. And I just love it. I'm having so much fun with it. And when I'm not doing those things, speaking of loving, I just love these people. I'm hanging out with these people. These are my wonderful family. And where do I work? I live and work in the United States in the great state of Michigan. Michigan is the one that's shaped like a mitten. It's shaped like your hand. If you look on a map of the United States, it's the one surrounded by water and it's shaped like a mitten. And we all use it as a waterproof, customized map that we have in our pockets at all times. This is what my office looks like 11 months out of the year. And this is what it looks like about 1 month out of the year. I took this picture this morning. That's my daughter Sparrow picking some daylilies and eating them as fast as they grow. It's a lot of fun. So I would like to show you something. It's not often that I get to speak to a more generalist data visualization audience, so data people. Typically, it's more specialists, cartographers, GIS analysts, and geographers, and that kind of thing. So this is kind of a treat for me, and as such, I like to show people this. So I'm going to do a search here for NASA fires data. I'm doing this live without a net. We'll see how it goes. NASA fires data. So nasa.gov has this great resource of a set of satellites, so robots whizzing around the surface of our Earth, looking down at it, collecting all sorts of data in different wavelengths of the electromagnetic spectrum. And some of those wavelengths are associated with fire events. And they collect those pulses of fire events and give those freely via the internet. So a nerd like me can go to this website and say, oh, look at this. I can download a text file of satellite data over the last 7 days covering the whole Earth. I'll just click this and it's done. It's a comma separated table here. It's a CSV. And if I open this up, it'll just open it by default in Microsoft Excel. You all are data people, so you're probably not using Microsoft Excel, are you? Are you? I use Excel all the time, and I know a lot of students use Excel or Sheets. This would also work in Google Sheets. So here we go. Let's take a look at this data. I'll expand this content so we can see what we've got. We've got latitude and longitude, which is intriguing for a map nerd like me. Brightness, scan, and track have to do with the orbital path characteristics of the satellites, thinking in columns and rows and that sort of thing. What time was it acquired? Which satellite was it that did the detecting? Was it satellite A or satellite T, because they're offset from each other? So there's never a gap in coverage as they kind of spin around the Earth. There's a partner satellite on the other side of the Earth collecting data. So the lidless eye of NASA is always watching. How confident is the post-processed value that is actually a fire? And then something called FRP, which is interesting. FRP, I had to look this up. It's fire radiative power, and its units are in kilowatts. I don't know what the units are. I forget what the units are, but a bigger number means more energy is being released at that location. So bigger fire, bigger number equals bigger fire. And was it day, night? Was it daytime or was it nighttime? And let me just, does anybody ever use, maybe you can chat in Slido. I guess you're all muted, and so it's just me speaking into what feels like the void. But sometimes I like to free myself from the tyranny of columns and rows as they have been delivered to me. And I think, how can I mess with this data and pivot it here and there and get different perspectives of the same data? So I'm just going to grab all these columns and I'm going to insert pivot table. Now, pivot table lets me slice and dice the same exact data in different ways. For example, I can take, let's see, I'll look at which satellite did the recording. So was it satellite A or satellite T? And you can see that over here. There's 2 satellites. And then I can say, well, did they capture the fire during daytime or nighttime? And I'll drag this as the columns. It's the same data, I'm just repivoting it. And then I can take that fire radiative power, for example, and drag it here and just sum it up. And we look at this little table, and this is a lot of fun for a map nerd like me and a general data nerd like me. But when I look at this, I don't intrinsically have a sense for less to more. I can kind of get a sense that this is more, but really just because I can see more digits here, it looks like a bigger number, but that's not really an effective, intuitive, intrinsic way of understanding this data. So as a map person, I like to break out the crayons, or crayons, as we pronounce them here in Michigan, in the Midwest of the United States. We don't have time for 2 syllables when it comes to crayons. We just call them crayons, like cranberry. So I'm going to grab these 4 cells and I'm going to color in. So I'm going to go to the Home tab and I'll do what's called conditional formatting here. I would call it thematic mapping or choropleth. And I'll just say, boom, white to red, small to large. Now, immediately, my mind can look at this and intrinsically have a sense for more and less and everything in between. It's a wonderful way of understanding data very quickly, but we still have the benefit of the specific data that we can more slowly and carefully interrogate, which is fun and interesting to me. So let's go back to this data. One day I was pivoting away because it's just what I do for fun. No, I had to make a map or a chart for a map. And so I was doing a pivot table and I thought, you know, latitude and longitude are pretty interesting. And I'm a geographer and I think of latitude and longitude a lot. And I had an evil idea. I thought, what happens if I shorten this? So I'm going to do a formula here. I'm going to round this down to the nearest whole latitude, and I'm going to give it 0 decimal places. So instead of latitude 59.99204, it's latitude 60 degrees. Now, if you have a problem remembering the difference between latitude and longitude, or longitude, as I would say, here's a tip. I don't have that problem anymore, because at one point somebody taught me a trick. It is latitude is like going up and down a ladder. Ladder, latitude, ladder, latitude, up and down the rungs of a ladder. Never had a problem with it after that. And then longitude is the other one. So let me flood fill this all the way down. And I just realized I don't have my compatriots here. I can't see your faces. So I wish I could see John, stop talking, you're out of time. But anyways, I'm just going to carry on. I'm going to carry on. And I'll call this lat. And then over here, I'm going to do a shortened version of longitude. Oops. Equals round, parentheses, I'll choose my longitude field, 0 decimal places, enter, 150 degrees longitude. I'll flood fill this all the way down. Now, how many fires are we talking about here? So this is over the past 7 days. And we've got about 100,000 fire events on the surface of the Earth, which is pretty interesting. And I'll call this long. So now I have a lat and a long. And if I grab these values and I just grab that fire radiative power 2, now when I insert pivot table, I'm going to enact an evil plan. So as a geographer who sometimes goes up and down ladders, I know that latitude is the North Pole, which is 90 degrees, to 0 degrees at the equator, to negative 90 degrees at the South Pole. North Pole 90 to negative 90 South Pole. And that's like, those are rows. If I'm thinking in terms of a Cartesian coordinate system, those are rows. So latitude in my rows, and then I'll just reverse that sort because that's what we do with latitude, because positive is at the top and negative is at the bottom. And then what's longitude? Longitude describes east-westiness, how far something is east or west. Longitude describes left-rightiness, left, right. And those are columns if we're thinking Cartesian in Cartesian space too. So let me just grab longitude and drop that into the columns area. And now I'm just going to grab fire radiative power and drop this into my values. And I'll grab everything and just make sure that these cells are roughly square because I'm fastidious like that. And I wonder if you start to recognize any pattern here. What the deuce are we looking at right now? When it comes to data visualization, we're always looking for structure. We see randomness and noise, we keep looking, we keep slicing and dicing until we see a pattern, until the structure of the Earth itself is revealed in our data. We just accidentally made a map of the Earth in Microsoft Excel. And Microsoft Excel has no idea that it's just made a map of the Earth. It becomes a map of the Earth when we recognize it as a geographic representation and internalize that and have the wisdom to recognize that this is a spatial product. This is a geographic picture that's accidentally rendered in Microsoft Excel. Microsoft Excel is happy to provide this to me in rows and columns and aggregate numbers into cells. Let me just grab everything here and I'll come home and I'm going to make these font sizes pretty small. And I'll make the background color black. So I'm going to start with like a black canvas because that looks cool. And looking cool counts. If your data visualization looks really cool, people will stop and they'll take a close second look. Good design is the currency that buys a closer second look. And that's valuable. It's not something small. It's not something insignificant. Now, I'm going to do some conditional formatting here. Color scales. I'm going to go to more rules. I don't want 2 colors. I want 50% more colors than that. So I'm going to choose a 3-color scale. And the lowest 10 percentile, I'll give like this cool, deep, cool blue. The middle 50 percentile, let's give it just fire red, no problem. And then the highest 10 percentile, or the 90th percentile up, I'll do yellow. So we get like this kind of flame gradient. This looks like the gradient of a flame that we would see. That's called natural mapping, not geographic mapping, but in design, the concept of natural mapping mimics the real world environment into an interface. And in this case, or in this example, these cells are an interface to the data. So this is a natural mapping color scheme. I'll hit OK. And now we've got a color-coded aggregation of global fires rendered in Microsoft Excel, delivered to us via robots that are orbiting our planet right now, happily sending data down to nerds like me, sitting in their usually snow-covered woodsheds in Michigan. What a time to be alive. I love it. I'm going to close this, and I'm not going to save it. Here's another map rendered in Microsoft Excel. This one is showing global earthquakes over a 100-year period. So when we see this, are we looking at earthquakes? This is another interesting concept here. So this is made in Microsoft Excel. This is a pivot table, color-coded pivot table, aggregating global earthquakes. Now you might start to see a pattern. You might see some structure that's been revealed. Now, when I look at this, understanding kind of washes over me, and I just can't believe the world that we live in. It's so wonderful. You have all these seemingly unconnected points of data, which in this case is earthquakes. But when viewed in aggregate, something happens called emergence. Emergence is when an underlying, more foundational structure reveals itself in the chaos and detritus of one order above it. What we're really looking at right here is the tectonic plates of the surface of the Earth itself, revealed via thousands and thousands of earthquakes. I just think that there's something magnificent about emergence when you can find it in big data. Here's another one. This one shows tornadoes since 1950 in the United States. That's there's me over here in that little hotspot of tornadoes. That's great. Isn't that great? So I'm showing you this. Why is this map guy just doing Excel demos? Well, I want to demystify things and explain some things. And the thing I want to say is geography is going to find a way. The planet that we live on is our home. And the phenomena that we measure, the people that we are, is all based and rooted in the concept that we're sharing this planet. And so any data, even social science data that we see, if we map it in enough aggregate, we start to see reflections of the planet itself that we live on. Geography is going to be emergent, and it will find a way. Another thing that I want to say is spatial is different. It's not just a number value. It's not just a Cartesian number. You've got the surface of the planet, and everything is happening on the surface of this planet that we're measuring in earthbound maps. Anyway, so spatial is special. That's a kind of a cliche that we like to say in the map world, and I just said it out loud. I didn't think I was going to say that today, but I did. Spatial is different. And lastly, I want to say that software is not the boss of you. These are just tools to help get the ideas that are in our heads and the curiosity that's in our mind out in front of other people so that it lands in other people's minds, ultimately settling in their heart. And I think there's something wonderful about that. And as somebody who's not incredibly technical, I find some comfort in misusing tools to perform things that they weren't designed for. I think it's great. And we do it all the time when we're kids. When we're little kids, we play with Lego and we don't follow the rules. We just assemble them. But over time, we follow the directions and then we get very regimented, and you enter into Lego competitions and there's rules about what you can and cannot do. It's always a good idea to breed a little bit of chaos and a little bit of R&D and a little bit of curiosity into our workflow instead of just being so busy all the time. That conveyor belt of work will never stop unless we steal some time to answer some of the questions that we have. This is an illegal move in the Lego building competitive environment. They call this an illegal move. And I say, illegal? Why? How else am I going to get my Star Wars TIE fighter wings on sideways without this illegal move? Why is there a perfect 2 millimeter gap between the studs and a perfect 2 millimeter height to the brick base? I ask you that question if it's so illegal. If you can do it, do it. Lastly, I want to show you this, visualization also rendered in Microsoft Excel. This is not showing you geographic data. This instead is showing you incidents of traffic collisions that involved pedestrians. And it's pivoted so that the time of day is columns. So left, right is showing you the time of day, and up, down is showing you the season of the year, the month. And anytime we see a structure in our data visualization, we have to start asking questions of it. And there's an enormous cliff of risk that happens in the evening at dusk. And it's because there's a confluence of factors happening. More people are driving home, and more people are out walking, enjoying the nice weather because they are home. And that combination of factors increases the likelihood of transportation-related incidents for pedestrians. But why does it bend? It bends because of seasonality, because our different number of hours of daylight. Yesterday was the summer solstice, the sunniest, most sun-drenched day of the year on our curved planet. And because we have a curved planet that has an axial tilt as we go around the sun, the data that's not geographic, which is purely human collected data of people and tragedies that's happening here, reflects the curve of the Earth itself. This is not geographic data, but it is geographic data. Geographic data is underlying almost all the data that we work with. So I wanted to leave you with that thought. Here's a little bit of contact information. Feel free to reach out. And I'm happy to have presented today, and I'm so glad my computer worked this whole time.
Thank you, John. I'm so happy. I mean, your optimistic and positive way of seeing today's world, I love it, because I really think we are really living in a very interesting time, and I think there is a lot of potential. And geographic data I think it is really a very promising discipline, and we need more.
Thanks, Ryan.
Speaking of, I would say, Nico, are you ready for the third talk?
I am ready for the talk. Thank you so much. Yeah, and John, I might add, like, what a beautiful place you live in. And like, there's something really wholesome about like seeing you craft maps in your house. That's awesome. Like now, every time I see a map made by you, I will imagine you in your house crafting them. And it's going to be great. Cool. So my name is Nico. A little bit about me. I currently work at Meta, building maps for the Reality Labs organization, which works in AR and VR. Previously, I've been a director of engineering and head of data visualization at Uber, where a few awesome open source work has been out from like DeckGL and KeplerGL and others. And before that, I used to work at Twitter, and I did data visualizations, mostly working on visual narratives for how different events were lived on Twitter, like the Oscars or any other sort of like mass event. Here's a picture of me at the Meta office in front of an artwork called Manhattan Memories Map, which was produced by the Studio Maravillas. And my interests in general are in data visualization, computer graphics, computational design, mathematical art, and digital fabrication. So let's talk about maps. Maps, we all know them as a graphic representation of the physical space, the stuff that we live around or in. We want to map it to a scale where we can browse it, we can hold it in our hand, we can fulfill the needs of orientation, navigation, and exploration of things around us. That's what maps are. But maps have been around for quite a few years. Like, this example is about 5,000 years ago. And it's taken from the book, The Story of Art, which I highly recommend. And it's the tomb of Nemaamun. And what's interesting about this artwork that you can find in the tomb is that it has a methodology that is very similar to mapping. And it has a methodology that is also very similar to sort of like dimensionality reduction, where you want to like basically take in three-dimensional objects and map them into two-dimensional space, but you want to choose your two dimensions in a way that you have most of the information packed in those two dimensions. So you don't just go ahead and flatly project it into some axis. So in this case, you can see this work happening, for example, with the trees. The trees are being looked at from the side. Even if we're looking from above the pool, the trees are looked from the side because that's the angle where we can get the most information from those trees. The pool is seen from above because if we saw it from the side, we would not get as much information as seeing it from above. And the fish are looked at from the side because it is the angle and the two dimensions that convey the most information for each one of these elements. So this person was really practicing a really interesting projection method by object, where the level of dimensions that were used and the dimensionality reduction was conveying the most of the information at each time. And they had a lot of consistency. If you look at a lot of the Egyptian sort of like artwork, there's a lot of consistency with this. We try to reduce the dimensions, but keep the dimensions that have most of the information in them. So how maps work? There's three main elements for maps. There's scaling, projections, and symbols. Symbols translated directly from data visualization work, the world from mapping visual marks and channels over to data. And on the scale, first of all, we want the map to have some form of scale because we want to be able to hold the map in our hands. We want to be able to browse the map, but also because at different scales we get to see different visual features from a map. And so we can see the topology of the map. We can see the topology of the road networks. We can see how land use is being utilized. And so the scale, it provides like different ways of aggregating data and different ways of finding different visual patterns within the map. Another type of scale, for example, is for indoor maps. So the maps not only have to be happening outdoors, maps can happen indoors. They're pretty useful, for example, for, well, VR. Like we might need maps in VR to be able to localize ourselves so that we can track ourselves as we move around. Like most of these devices have 6 degrees of freedom for movement. We might want to map our house because we want to use AR to set some furniture in our house and figure out how it looks like. We might want to map our house because we want to augment it with digital objects that are, anchored on the walls and other places. So the scaling for mapping also works, and maps are not only outdoors. Finally, I wanted to leave you with this thought on scaling, which is that, I do believe that there's a little bit of a change within human-computer interaction techniques happening due to some of the VR work. And this is one of them, right? We're used to seeing maps as physical objects in 2D flat space, or looking at maps as on our mobile device where we can zoom in and out. But maps here can take a completely different, more immersive role, where we can have tabletop maps as we're sitting at the table, and then we can dynamically move and change the actual scaling for the map, and we can be in the map as well, exploring different details of locale where we are, located. And so this is pausing for me, lots of new questions of how to interact with maps and how to use maps for exploration that, before were probably not possible because we were using different kinds of computers. So the second piece is projections, and you might ask yourself why there are so many map projections. And the problem with map projections is that when you translate from 3D space over to 2D space, you need to make some trade-offs and some compromises. Usually these trade-offs and compromises are around area and preservation of angles, or we call conformality. And so, for example, this is a perfectly normal, quote unquote, map projection, the Mercator projection. You'd think it's great, but then if you are trying to compare areas for different objects, you see how they get really distorted, right? So this projection is great because it preserves angles, but it does really bad at preserving areas. And so you get a lot of these sort of distortions or even visual illusions for different sizes of things. So the conformal projection, which is really good, can be seen with this, what we call the Tissot indicatrix. So imagine that you kind of draw circles on top of the globe, all of the same radius, and now you unfold the globe into your Mercator projection. So this is how the circles would look like, the discs would look like. So basically, the discs remain discs. So circles remain circles, which means that angles remain the same angles. However, the areas of the discs are changing as you're moving up and down the ladder of latitude. And so this shows you the level of distortion and the type of distortion that happens within this map projection. Now, here's a good projection, pun intended. It's a projection that is supposed to preserve both area a lot better. And what you can see here is there's a thing that's creeping in, which is the fact that we need to make more cuts into the map. If we want to be preserving, angles to some extent, and also be preserving area to some extent, then suddenly we need to be slicing the projection and the paper a little bit more as we stretched it on the surface, which gives us this sort of interesting sort of trifecta or interesting sort of dynamic across these different constraints of map projections. We have this triangle. I'll explain what it is. On the bottom left, the vertex on the bottom left are all projections that are equal area. So if you want it to be 100% equal area, you go to the bottom left. If you wanted to preserve angles, in perfection, you would go to the Mercator projection, which is at the bottom right. Now, what happens if you want to preserve some area and some angle and not be super distorted in both? Then you start moving up. And as you move up, you see that we need to do more interrupts and cuts to that paper. Similar to what, when you're peeling an orange, and if you want to put it on the table, you really need to sort of create all these different cuts on the skin of the orange. And so when you get to, there is a place that is the top vertex where you can find maps that are both equal area and conformal maps. which is called Myriahiral projections. And so this is a paper that Jark van Wyk published more than 20 years ago with a lot of really interesting set of map projections that both preserve area and angles at the expense of creating lots of cuts. So how does this work? Let me quickly walk you through the project. Hopefully everything works. So this is live projects have been coding in WebGL. The idea behind it is you have a mesh, which is a spherical mesh. In this case, it's a graticule mesh. So it's divided by latitude and longitudes. And then you create many surfaces in the mesh, like so you subdivide it multiple times. And then you assign different weights to the edges of the mesh so that you can create cuts and then unfold it, mimicking some sort of map projection. So in this case, we're preserving both area and angle, but we're creating all these different cuts at the longitude level, right? We can also kind of mimic other common map projections similar to the equirectangular map projection, or if we were to separate into two map hemispheres, we could do that too. But since we have that sort of like finer grain ability, we can also cut and leave like land in one piece and then cut through water as well. And now we can start getting creative with this methodology. We can get a mesh that is not a graticule mesh, but we can, for example, get a tetrahedron and start subdividing the triangles of the tetrahedron into a sphere. And then we can assign weights in a way that sort of like in a fractal way unfolds the mesh. And so now we have, like, you can see the four faces of the tetrahedron being subdivided multiple times. You could do this with sort of like a cube as well. So you can see the 6 faces of the cube with this recursive subdivision. You can also kind of like change the center of the map as well if you wanted to the center for the projection to be somewhere else. And then finally, what Van Wyk did was also look at like the actual platonic solids. So if you were to get a cube and you wanted to find cuts in that cube that don't cut the land, how would you position and project your map on top of the cube? And so these are some solutions for a cube. This is a solution for octahedron, for example. This is a solution for a dodecahedron, which unfortunately does cut some land, but it tries to minimize it. And then we have a bit more sort of like complex shapes around Archimedean solids and others that you can take a look at. But that's the main idea. So back to the presentation. The idea is we start with a mesh, we create the weights, and then we unfold the mesh to create these sort of visualizations. So finally, I want to chat a little bit about symbols. So this is taken from Jacques Bertin's semiology of graphics, where you find a categorization of data into ordinal, quantitative, categorical, and then you try to map those and rank them with the different visual marks and channels, which are the ones that are here. And you can use those in maps as well, right? This is a very classic map of Jon Snow, where we're using dots or different marks to mark deaths and also mark where the water is being pumped and create that sort of visual correlation between water and cholera. There's these beautiful maps by Erica Fisher on sort of like the different local versus tourists and different coloring coding, or different coloring coding for different ethnicity at different cities, which really show the richness of the humanity living in each one of these places. This one is a really interesting one because it's a multivariate sort of analysis on a map, also taken from semiology of graphics, where you're mapping the size of the symbol to someone's height. You're mapping the color of the symbol to the color of the hair of that person, and you're mapping the shape of the symbol to the cephalic index. And so you can quickly do multivariate queries within the map themselves and get some interesting insights. We've talked about choropleth maps, so I actually quickly jump over these, but we're in this case using the actual shape of the county or the state and then coloring that, and that's our visual attribute. Then we can start playing with the shape or the size of that county or state, and so we can start talking about cartograms. These are really good cartograms that Noah Wellman sort of like implemented in JavaScript from different newspapers that they've been using them for the US. There's cartograms like Dorling cartograms where instead of preserving the actual position for that state, you can move it around a little bit so it doesn't superpose or overlap with other symbols. And you get these really beautiful shapes of the state that are still very recognizable, but at the same time, positioned in a way that there's no overlapping. And classic flow maps like the Minard Napoleon March map, which is like a really good example of a flow map, mapping the line thickness with the size of the army. Flow maps has also been revisited quite a bit in the literature through edge bundling techniques. This one is visualizing different trips by plane, and the paths are being bundled in the edges. And then finally, what we want to end with is this sort of like vector field map, where we're using symbols to encode wind direction, speed, and temperature with color. But you can also use sort of like particles for it. So in this case, we can use the vector fields for the wind and simulate that by throwing some particles on top. But also we can use the symbols of the arrows to know at each point what the wind speed and temperature and direction is. And if we change the hour of the day with the slider, that sort of like we'll change the arrows, and then the dots or the particles will sort of like reposition themselves to create new vortices and other interesting phenomena that cannot be seen with this sort of grid of arrows. So just to wrap it up, kind of recalling some of Tufte's principles for analytical design, I'd say like, still though, think about your audience, because there's some of these that might get more important than others if you're trying to create a functional map that can be explored, or if you're trying to create a data art, like, for example, content counts most of all. I don't know, if I want my map to look great in my living room, I might not care as much what data set I'm visualizing, but I do care about the aesthetics of the map. But all of these count, and so would make sure to maybe have a checklist of some of these before you start or while you're working on your map. And that's all. I feel like I raced through the slides, but thank you so much.
Perfect. Thanks a lot, Nico. Actually, it's really perfect timing, because I was actually a little slower with the introduction, but you made it perfect. 7 o'clock here, local time, so perfect. Yeah, for everyone, we have actually some questions. Still feel free to ask more questions in Slido. I was said to that I have to say, I mean, it's obviously we are on YouTube, so please make comments, upvote videos, and subscribe to the channel. So a little bit of YouTube commercial. Yeah, and probably at some point what we have today also new is that we were thinking how about bringing this experience also again to physical space. So actually we have next door we have a kind of a public viewing with some beers and pizza. So I think that at some point they would just drop in, say hi from the other location. I hope to have that more in future. Yeah, so yes, so let's switch to the questions. I will, as it is the most frequent question, I will combine it and I will ask all of you the same question. And the question is a little bit, what is your background? How did you come? Did you study something at university? How does such a career path come together so that others can kind of try to follow and kind of make also such great projects as you do? And also combined to that question is to first kind of background and career path, and coming to what tools are you using, kind of what kind of coding tools, especially that was probably the first question which came up when people saw Craig's project. Okay, so please feel free. Maybe Craig, you were the first one. Maybe you can tell us more background and coding tools.
Yeah, sure. Okay, so I mean, my background, probably like most GIS folk, was geography at university, and I did a master's in, well, back then it was called environmental information design. So not 100% GIS, but it was very sort of, remote sensing, GIS analytics, that kind of stuff. But it was great. It set me up for a career in mapping, basically, and I sort of, I guess, I started out in kind of typical engineering companies, doing sort of I guess basic utility mapping, and I guess joined more innovative companies working on foreign projects, which was really fun. And I guess, yeah, I ended up at Ito World, where my sort of interest in 3D design and animation sort of led me, really. So I guess the tools and coding languages that I oh, hello. Lots of people. Yeah, no, it's cool. So tools and coding, like I use, well, we have internal tools at Ito World that we sort of analyze, lots of data with, and that's really useful. The 3D stuff is, most of the workflows are done through a software called Houdini, which is really, really cool for everything from VFX to all sorts of, crazy designs that I sort of put in my visualizations. But everything is underpinned by GIS, like whether it's, an Esri thing or a QGIS thing or whatever software package it is that you use to analyze data, it all starts there, basically.
Cool. Wow. Okay. Super. Sorry for there was an interruption. Sarah, you say hi from the other side. I guess you have an echo now because of the stream, right? So all good there? I don't see beer and pizza. I will join you. Okay, good. Okay, yeah. Sorry for this one. So John, well, how about you?
My like Craig, my background is in geography. Academically, it was GIS. They called it the techniques when I went through. So there's physical geographers and then the techniques, people like, pushing buttons and using tools, things like that. But also art. So I minored in art with an emphasis in photography, which is, capturing light and understanding wavelengths and using filters and balancing a composition and creating layouts. And there was so much overlap between the art classes I was taking and the geography classes that I was taking. Remote sensing classes had a lot to do with photography, of course, and the cartography classes, there was so much overlap. They were saying the same thing. They were just wearing different outfits. And I most of my career has been, technically I've been paid to be a UX designer, even though that's not my background. But I've found a lot of overlap between map makers and user experience designers. And it's probably a combination of some things. The sort of person who enjoys making maps is probably also the sort of person who enjoys making user experiences. But that's not a coincidence, because maps are a user experience device to spatial data. And so I see a lot of people who are cartographers and GIS folks who are also really great user experience designers. So my official role has usually been UX designer, and then I steal time to do cartography on the side. But I did enough of that when I joined Esri, I get to do a lot more official cartography work in addition to UX. I don't have to steal time to design maps now. It's great.
So that means you are totally interdisciplinary and kind of shaping the new term, not user experience, but more spatial experience, SSX, spatial experience design.
Sex. Spatial experience design.
There we go. That's a good one. Okay, nice. Cool.
Yeah. As far as tools go, I mean, I really benefit from the complement of tools that Esri makes. But I mean, you just saw me make a map in Microsoft Excel. So there's this underlying urge in me to misuse the tools that are available to me to get where I want them to go. I mean, if you have a hammer, then everything looks like a nail. But if you're just thinking about driving nails, then you can find hammers all over the place. You know what I mean? So it's not a tool-centric perspective. It's a work-centric, goal-centric perspective, and you just use what you have to get there. And I'm not a developer. I can't code. I can only manage to almost not break markup. So that's as good as I get as far as as code goes.
Well, it's cool. Cool. I think people also liked it a lot. They said kind of that you don't need the greatest tools to make cool stuff. So it's good. Nico?
Yes. So my background is in engineering, software engineering, and computer science.
Yeah.
And then I got excited by data visualization. It was a kind of like a visual programming class. They were showing this sort of like hyperbolic tree visualization, and I got all excited about it. And then since then, like, you know, I spent a bit over a decade just doing data visualization work. And then I think that like I intersected with maps at Uber, where a lot of the visualization was of mobility data. So we were visualizing pickup and drop-off locations, GPS traces, mapping data, dispatching algorithms, perception prediction and motion planning data for self-driving cars. And so it ended up being mapping data just by the circumstance. And that started my journey into mapping. But I am a very like visualizations. I'm a very attracted by visual stuff. And so I also feel like maps is that like even the data structures that are used to store and index map data are very visual in themselves. The quad trees and all these different things are in, at the end of the day, like are very visual type data structure. So you can reason visually about it as well.
Mm-hmm. Now you said something, aesthetics. So kind of it was also asked kind of the importance of beauty in maps, kind of to get the attention, but also kind of readability, kind of when is that shift, and the importance, kind of when do you, and probably also connected to that one is kind of this explorational aspect of kind of analysis, but also the other side of kind of the presentation side. So what's your approach or your kind of the philosophy behind and the importance of each of it, aesthetics and functionality and analysis? Who wants to start?
I'm happy to go first because
please.
Other answers are going to be a lot richer than mine. But I think that like the first question that might be useful is like, what is it for? And back to that end goal, like, is a good map something that is like, aesthetically pleasing, that I like to look at, that I like to get lost in, looking at the different details, if it's like a big poster, or something that, feels like organic and like, colorful and visually, attractive, or, am I using the map to perform a task? Like I'm, on a ship and I need to navigate from A to B and I need to understand this with a map. Like I'm, like at that point, like I guess the aesthetics are useful in terms of like, how the human eye works and what the different contrasts are and how to make the data the most legible possible. But it's less about, the end goal of like just, and sometimes like there's accidents where you want to make something that's incredibly useful, and at the same time also it is visually very appealing, and it can be both. But what I'm saying is like people who make beautiful maps should not apologize if they're not very insightful, and people who make insightful maps should not apologize if they're not beautiful. I think that these things can coexist pretty well. That's my personal opinion.
Very nice. What do the others think?
I agree. That's a good point, Nico. They aren't, it's not a tension, and it's not something you have to balance. They're complementary and both valuable. It's not one of more steals from the other, It's not a zero-sum game when it comes to aesthetics and communication. Edward Tufte has a great quote that I think about a lot, which is, good design is clear thinking made visual. And that can take the form of any number of visual iterations. If Craig, Nico, and I each had the same data, the resulting visualization would be wildly different, each of the three, but they would probably all show some interesting facet of the data. And we would bind ourselves up a little bit in the creation of those, and that would manifest itself in the result, because we're different people. We have different backgrounds and different interests. And that's why it's so wonderful to see different people map the same data. There's no one right way to make a map. And that's a freeing thing once you really embrace that. There's no one right way to make a map.
Mhm. Cool.
Yeah, I guess completely agree with what's been said so far. It's like at the beginning of my presentation where I was talking about, art versus insight and where my work falls on that spectrum. And it's always, I think it can get a bit difficult sometimes, because there's always like a justification that needs to be made of why I've created something that is just something that just looks nice. But I guess through my career, and certainly over the past few years, I've started making less apologies for just making nice stuff. Like, it can just be experimental. It can just be fun. It doesn't need to have, 10 different caveats on it. Whenever you post something, it could just be fun. Like the whole bus story thing. Like, who wants to know what the loneliest bus is? It doesn't matter. It's just, it's just you having fun in your discipline. And I think that's the most important thing for me. We have lots of clients where we do very insightful work for, and their needs are a lot different. We have internal tools that are validating, and that sort of workflow is very different. But from a personal point of view, when I'm posting these fun visuals, it's just kind of like freedom, basically. It's like what John was saying. It's a freeing thing to be able to post something and create something and not worry too much about having to justify it.
But does it mean that the client projects are not fun? Or
No. Yeah, no. I didn't quite mean it like that. But there's more rules attached to client projects, right? So okay. It's they don't want coral cities all over their visualizations, for example. It's they have their branding, they have their goals, they have their stories they want to tell. So it's as fun and as creative as they can be. It's we are still. It needs to be insightful, it needs to be engaging. So there are rules that we have to follow for them sort of visualizations.
And how are you testing readability? Do you test readability, or do you kind of, all this kind of user testing and so the stuff, do you do that, or kind of you just see if people can read it, or how do you do that?
I guess it's tricky with, so we have a set of products that we build that undergo lots of usability testing. With the stuff that I was showcasing today, the kind of fun stuff, it's tricky to sort of undergo that kind of strict procedure of is it this, is it that, and I guess it completely changes as to sort of what I'm doing. There's lots of, like I was talking about in the presentation, there's lots of caveats with 3D design, occlusion, scaling. There's all sorts of problems that lead them to not be as insightful as a sort of like a 2D map, for instance. So it's always a tricky thing to navigate through, especially in 3D mapping. But we try as hard as we can to make the data clear, to make the message clear, and using 3D lets us use different axes of data, which we can't necessarily do in 2D. So it gives us a bit more freedom, but with that comes issues as well, I guess.
Nico, you are probably doing a lot of user testing, right?
Yes, for certain things. Certain things are in production, so the user testing is really end user testing. One feature that's using maps at Meta is the Instagram map. So if you use Instagram and you see a location tagged in a post or a story and you tap in there, we take you to a map that you can browse to do sort of local discovery. So discover places near you that could be interesting for you. And so there's definitely testing there. For other things that, I referred to around the HCI side of things, like there's more sort of like user research involved, and some user testing, but it's like the population that's been testing these things is a lot smaller.
Okay. John, are you also in projects with checklists and readability guidelines and user testing involved? Are you involved there?
Well, a lot of my work is intuitive. So thinking of how I would finally understand something when I ask the subject matter expert a ton of questions because it takes me a while to actually understand something. And then when I finally get it, oh, aha, I kind of backtrack and try to draw a picture of what it was that got me to that understanding and make that visual in a user experience and focus on that element where I discovered what it actually was that was important. User experience testing, however, the apps that I do don't get a lot of specific user experience testing before they're released, but we do use components that I have, individual user experience testing and some best practices for how to implement those controls, that sort of thing. But the overall assemblage of those things is so specific to the apps that I make, maybe, loading different satellite images from different dates and which component you do and how do you compare those and how do you quantify the change in visually and in charts and that kind of thing. It's a lot of invention, and so we can't rely a whole lot on past work that we can kind of rubber stamp forward. But I don't know, that's kind of a vague answer, a non-answer.
Well, I would say the intuition. The first word you said, intuition, I got it because that's my thing. Yeah.
Intuition is big. And people with intuition who invent things, eventually that gets documentation wrapped around it and becomes a template for other people to use and say, well, I'm using this template.
Yeah. I see that. It got so dark here. We got a really crazy thunderstorm just currently. Looks quite spooky. That's why I had to turn on the light. Okay, so I have a last question. It's actually my favorite question. What would be your favorite project? Maybe it's the project you're working on currently, but kind of what is kind of this ideal cool thing, data or topic you would kind of love to work on in the future?
I can go. So I think my favorite project is
great. Yeah.
So a while ago, I did a project I called Plot My Paws, which was me putting a GPS tag on my Cocker Spaniel puppy and plotting him as he ran like a lunatic around a field.
Okay.
That was probably the most fun I've had in a project, and took it to ridiculous levels. I actually got the local village to let me put tags on all of their dogs as well. So I had an absolute mass of data on how dogs run around our local conservation area, which was okay,
fun. Let's do that now on a global scale. So everybody who's watching and is hoping just contact Craig. So let's start the global puppy tracking mapping initiative.
Plot My Paws, you heard it here
Plot
first.
My Paws. Yeah, good. Cool. Love it.
I'm happy to share my screen a little bit to share something, but essentially, like some of the myriahiral projection work that I showed sort of took me to just projections in general and across different spaces. So from a sphere to a plane to a hyperboloid, I guess. And so I'm very much into symmetry. So it's a little bit away from maps, must admit, but it does have some nuance to it. And I actually was looking at the Behance from Craig, and he has similar things as well with little cities that are contained within little worlds. And so I'm trying to patch a city and put it on a sphere or put it on a hyperbolic space and see what happens, and then try to use the axis rule for some of these things or 3D print them. So it's been pretty like a good sort of source of crafting on the side and learning as I'm doing. And it's been fun. So that's what I'm up to lately.
Nico, that
Super.
reminds me of a person named John Paul who fashions his own footballs out of leather and stitches them together and has to plan the three-dimensional, because it's an enormous amount of work to actually make sure that the tolerances are tight enough that when he stitches together the pieces, it assembles into a workable football. And it's
That's
a
awesome.
great channel. Yeah, John Paul's Balls. It's on Instagram
John
and
Paul's
YouTube.
Balls.
Yeah.
I'll look it up.
Yeah, you'll enjoy it. And what I appreciated about it is he shares his creative flow and his path, which is always interesting to me, no matter what somebody's creating, whether it's a map or a table, a wooden table or soccer balls that somebody's hand making. I really like learning about people's creative process. You'd enjoy it.
Super. Great. John, your
Yeah, can you remind me of what the question was?
the question
got
was
thinking
your
about
dream
footballs,
project.
and then I
Your-
lost it all.
Yeah, it's the dream project,
dream.
dream data.
I don't have one of those.
Yeah.
The maps and visualizations that I make are really kind of just snowballing one to the next organically.
Yeah.
And so I don't have any like big goal in the future that someday if I can get my hands on this data. But I
Okay.
do have a user experience project that I'm working on right now with some colleagues that I'm really enjoying. It's a remote sensing expert on the team named Robert Waterman and a really great developer named Jinan Zhang. And we're trying to make it very easy to understand and access and even download satellite imagery data, because right now the interfaces for that are intimidating and a lot of them can be very difficult and kind of clunky or specialists, or if there's instructions from the institution providing them, they'll say just fire up this script and well, you lost 95% of your potential audience. And so I want to remove that barrier. And so I've been having fun doing that, because it's a pain that I've felt in the past, is when I see like, well, you simply write this script to download this imagery. I'm lost. I can't do that. So that's a lot of fun I've been having. That's kind of a dream thing, or at least I'm trying to solve a problem that I've felt in the past.
That's really important. Yeah, it's important work. I see that also with other databases and other data, like United Nations and so on. Always the interface to get that open data is quite sometimes painful. Yeah. Cool. Okay. Yeah, I would say we stop the stream for today. Thank you, everyone. Thank you for all the 500 people who joined so far. Was great to have you here, everyone. So we are closing. See you next session.
Thank you for
Bye-bye.
having us. Thank you.
Yeah, thank you for the invite. Goodbye.